Today we will discuss on a very interesting topic that are internal relays that are present in PLCs. Now you see that such type of relays are actually not present physically, but they are all software simulated. They have every characteristic of an output coil, but you cannot take their physical connection outside the PLC. Presence of such relays, they actually help to solve several ladder problems very simply, especially when it is required that some output condition needs consideration of several inputs and it is a multi-stage operation. Then the internal relays play very important role. And many times I could find in several programs that I have developed in different control situations that if there were no internal relays, perhaps it would have not possible for me to develop that program. So let us see actually what are the internal relays. Now you see, these are the elements that are used to hold data. Data means I am talking of bits because it is a single bit thing. So data means bits, bit of data, and they behave like relays. They are able to be switched on or off, and they can be applied to switch other devices on or off, and therefore they are called internal relays. However, internal relays do not exist at real world switching devices, but they are actually memory, bits in the memory that can behave the same way as a relay. Now you can see if you want to program them, they can be treated in the same way as external relay output and input. You can use it very easily. You can put it in the ladder diagram, then you can apply it for controlling external relay inputs or outputs. There is no problem, absolutely no problem. Again, inputs to external switches can be used to give an output from an internal relay. This is also possible. This then results in internal relay contacts being used in conjunction with other external input switches to give an output and whatever can be the load. Now you see this line is very important. Inputs to external switches can be used to give an output from an internal relay. Now this can be further applied towards using the internal relay contacts in conjunction with other external inputs to give an output. So this is one thing, that you are having one external switch. This switch can be used to activate an internal relay. When the internal relay is activated, the output of that internal relay can be applied to activate another external relay. So that's why it is said that internal relay contacts in conjunction with other external input can activate a load. So this is a very interesting concept that you can use. As I have told, they are exactly the same as external relay contacts. But while you use an internal relay, it has to be activated on one rung of a program. So you can see here, this may be the first rung where that internal relay coil is there, and NO contact of this coil is present in another rung. You can see here its output is used to operate switching contacts on another rung, or you can use this particular NO in multiple number of rungs if it is thus required in the program. Now you can see this is another important line that you have to remember very well. Internal relays can be programmed with as many sets of associated contacts as desired. So if this is the coil and this is an associated contact, this contact can be used many times in the program. There is no limitation. Now you see there is requirement that we can distinguish the internal relay output from external relay output. Since their symbol is exactly identical, there is clear necessity that we are able to distinguish between one internal relay and one external relay in a ladder diagram. Now you can see different manufacturers use different terminology. In Mitsubishi, the auxiliary relay term is used and the notation is M. M is for memory bit, M100, M101, likewise. Siemens use the term flag. So here Mitsubishi either takes it in the name of auxiliary relay or marker. Siemens use the name flag. Toshiba use the name internal relay and Allen Bradley use the name bit storage in PLC 5. Now you see Siemens use the term flag and notation is used in this F0.0, FD0.1. Likewise, Toshiba uses it as R000, R001, likewise. And in Allen Bradley, we use the term bit storage. So this is B3001, B3002. Actually, these are the addresses. You may wonder why this is B3-/001. Why it is not B1/001. This is actually the memory map where they are placed, and accordingly the addresses have been given. Now you see that what is the basic requirement of internal relays. We are talking a lot about internal relay, but why they are required. Now for this I would like to ask you to consider a certain situation. You see, you have got a problem where a system is to be activated when two different sets of input conditions are realized. A system is to be activated when two different sets of input conditions are realized. So input conditions are two different sets. Okay. Now this may happen in a very simple manner where you have only two inputs. You have only two inputs, and according to the situation of the two inputs, you have to decide the output. This is very easy. You can use a logic gate, and the logic gate is AND, definitely. Now you see why I am particularly talking of AND, why not OR? Because you see here what has been written. The system is to be activated when two different sets of input conditions are realized. इसका मतलब क्या है कि both input conditions जब yes हो जाएगा तब तुम्हारा system activate हो जाएगा. तो definitely you have no option other than logic. ठीक है, जहां तक दो input की सवाल है situation बहुत आसान है. But now if a number of inputs have to be checked, in order that each of the input conditions can be realized. Here एक input condition के लिए there are number of inputs and many of such input conditions ultimately realize one output only. If this is the situation, then internal relay is the only answer. Might be in many cases. You can see the first input conditions are used to give an output to an internal relay. आप पहले input conditions को output में मत दे दो डायरेक्ट, you give it to an internal relay. अभी इस रिले की जो कॉन्टैक्ट है उस कॉन्टैक्ट को दूसरे जो पार्ट है आपके सर्किट का उसके इनपुट के साथ जोड़ दो, तब वहां पे आप दूसरी लॉजिक बनाओ, एंड फाइनली यू गेट द बेनिफिट ऑफ दिस इंटरनल रिले. वी विल टेक वन एग्जांपल. देखो, सबसे पहले यू डू नॉट ट्राई टू गो फॉर दिस लेफ्ट सर्किट, यू ट्राई टू अंडरस्टैंड द फिजिकल सिचुएशन. Here we need to lift a barrier. Barrier means एक लॉक गेट समझ लो, जैसे कि अपना डैम में रहता है ऐसा एक बैरियर को नीचे से ऊपर उठाना है. You need to lift the barrier automatically when someone approaches from either side. मतलब कहीं पे गेट है, जो गेट आपको उठा लेना है, गेट को ओपन करना है. अगर सामने से भी आदमी आया तो भी ओपन करना है, गेट के उस पार से आदमी आया, सामने से पीछे से बोलने से अच्छा है गेट के उस पार से या इस पार से, दैट मीन्स फ्रॉम दैट साइड ऑफ द गेट और दिस साइड ऑफ द गेट। कोई भी इंसान आता है तो गेट आपको आप खुल जानी चाहिए। सो नाउ यू कैन सी दैट हाउ वी आर ट्राइंग टू अंडरस्टैंड द प्रोसेस and then we decide how to put various inputs and outputs in this particular situation. Now one thing is for sure, that here there is only one output. The output is one motor that lifts the barrier. You have only one motor that lifts the barrier, and that is the only output in this circuit. But now you can see that this motor is having several input conditions that are to be considered. Number one is input 1 and number 2 is input 3. I have done it arbitrarily. The whatever nomenclature is, I have done arbitrarily. One is in input 1, I have got one photoelectric switch, and input 3 again I have got another photoelectric switch. Now what is the purpose of this photoelectric switch? That has to be understood very clearly. Whenever some person is there in front of any of the photoelectric switch, the photoelectric switch or the sensor, it will generate a signal so that the PLC understands that he has to lift the barrier or it has to lift the barrier. So one switch is present on one side of the barrier and other switch is present on the other side of the barrier. So here are the two inputs. Next, there is an input 2, which is an enabling switch to enable the system to be closed down. So this is a complete enabling switch, right? Input 4 is a limit switch that has to detect whether the barrier is closed or not. When the barrier is closed, suppose it is a limit switch, उसके ऊपर barrier आ गया तो limit switch close हो जाता है और activate होता है. So when the barrier is closed, the limit switch is closed and therefore it is activated. Now the result is an output from the output 1, a motor that lifts the barrier. Now you see, if the limit switch detects that the barrier is open and the person has passed through it, then it opens, and so output 1 is no longer energized and a counterweight might close the barrier. यहाँ पे आपको थोड़ी समझनी है. समझो लिमिट स्विच खुला है, मतलब क्या है कि बैरियर लिमिट स्विच के ऊपर चढ़ा हुआ नहीं है, तो पीएलसी को पता चल गया मेरा बैरियर अभी खुला हुआ है. नेक्स्ट, नन ऑफ द फोटोइलेक्ट्रिक सेंसर्स आर एनर्जाइज्ड. इसका मतलब क्या हुआ कि कोई इंसान भी नहीं है, ऐसा सिचुएशन में गेट बंद होनी चाहिए. तो अभी क्या हो जाएगा कि अभी दिस ऑफ योर इनपुट स्विच, अभी आप देखो इसका आईओ मैपिंग कैसे हुआ. इनपुट 1 is a normally open contact. Input 3 is also a normally open contact. These are the two sensors. Now this is input 2. Input 2 is again a normally open contact. So we need to close this or we need to open this in order to make the system run or stop. This is a master control. You can think like that. Now here you can see that there is a coil, and this coil is the internal relay coil. Now finally what they have done, this internal relay coil has been associated in AND format with the input 4. This input 4 is actually the limit switch that checks whether a barrier is closed or not. Now suppose the internal relay is activated. This is on. This is on means that either this input or this input both are on, or either of them are on. Okay, so now you see you have put this input into activated because this is the master switch, you have to activate it. Now suppose this input has become on. this input, what I will do, I will go for this PPT. Okay, it is not possible for me. You try to get it understood from this way. You can see here, if suppose this switch is on, under that circumstances I make this photoelectric sensor has sensed presence of a human being. So this will be closed. So when this switch is closed, your internal relay will be activated. When your internal relay is activated, this NO contact will become closed. When this NO contact is closed, it will check whether the input in 4 is closed or not. If the input 4 is closed, that means your barrier is in closed condition. Now, since this is on, and this is a simple AND circuit, your barrier will now be open. Now suppose your barrier is open. Your barrier is open means this is NO, this is open, no current can pass through it. There is no human being, this is open, so there is no signal from the internal relay, so this is going to be open. So this is not connected, this is not connected, so your output will get no supply. And under that circumstances, if there is a proper counterweight arrangement, then the counterweight will close the barrier. This is the goodness of internal relay. Now you can see the internal relay has enabled two parts of the program to be linked. Two parts of the program. One, this input from the photoelectric sensor, and other, whether the barrier condition, whatever is the barrier condition. So if a person is there, this is one condition of the circuit, and whether the barrier is opened or closed, this is another condition of the circuit. So both these conditions have been coupled with the help of this internal relay. Now you may have one question in your mind. Can this be the only way to program the situation? No, I never say like that. Because any particular control process, any process or any control situation can be programmed in many fashions. This is just one of the way that I have shown you. You can find a smarter way than that. You can find a more laborious way than that. Both can lead to the solution. But whenever you try to design a program for certain control action, you need to be smart, and you need to see that with lesser amount of equipment, lesser amount of contact elements, lesser amount of programming space, you need to cover a certain particular control action job. And that is the versatility or speciality of a good programmer with in comparison to I should say a newcomer in the field. Now in our next lecture we will see what is one-shot operation of internal relays. This is also very interesting, and this will be a very small topic, and we will cover it in our next lecture. Thank you.